I'm going to be going through how I created that space shooter game using Pygame. So first we'll import Pygame. And while we're here, I'm going to also import a couple more functions from 2 more libraries. The first will be from sys import exit. This will allow us to safely and cleanly stop the program. And finally, from random import, we're going to do 2 functions, randint and choice. Before we can actually code the game, we need to start Pygame, and in order for Pygame to actually work, we need to run pygame.init. This is kind of like starting the engine to a car. However, Pygame is not a game engine. Keep that in mind. It's technically a framework. So now that we have that out the way, let's set up the screen. So we'll create a variable called screen, and this will be our screen surface for our game. It's like the canvas that everything will be displayed on. And we'll assign it to pygame.display.setMode. And then we have to pick our size of the screen. I'll do 1000 pixels times 500 pixels. Let's also give our window a name. So pygame.display.setCaption, and we'll do Spaceship game. And now, like all Pygames, we need our actual game loop where we actually update the screen and the game actually runs and refreshes. And this will use a while true loop. While true. And the first thing we're going to put in here is pygame.display.update. So every time the game loop runs, we want the screen to refresh. However, all good games also control the refresh rate, and it's very important to control the refresh rate. If we don't control it, each computer will run the game at a different FPS, and the characters in the game will move at different rates. For example, let's say we have a character that moves 1 pixel every time the frame updates. So for one computer, if the refresh rate is 10, the character will move 10 pixels per second. Whereas if another computer has a refresh rate of 20, then that will move twice as fast, at 20 pixels per second. So that's why we want to be able to control our refresh rate. And we can do this by coming back up here outside of the while true loop, and we'll create a clock variable, and we'll set it equal to the pygame.time.clock. So this will create an internal clock for the game. To actually set the refresh rate, all we have to type is clock.tick, and then in here we put whatever integer. I'll just do 60. So this means that the game loop will run 60 times per second. So now let's move on to the actual structure of our game. And the game will have 4 parts. We have the home screen, we have the actual game where the game is active, we have a game over screen, and finally we have a cutscene after the player presses play and the player ship travels to the enemies to fight. And so for each of these, let's create a Boolean variable so the program knows which one of these to show. And if all of them are equal to false, it will show none of them. So for now, let's set the game active for true, because we're not too worried about the other 3. And in the game loop, we obviously want to create a section for each of these 4 parts of the game. So because they're booleans, we can do if game active, we can do elif game over screen, we can also do elif cutscene, and we can also do elif home screen. And we'll password these for now. And while we're setting up and doing some chores, let's also get this exit function from up here out of the way. The way Pygame works is that there are multiple events that Pygame registers. We have to check if an event is a desired event. So first we want to check for these events. So for event in pygame.event.get, this is a list of events. For each of these events that occur, we want to check if the event.type is equal to pygame.quit, and this is all caps. And what we want to do, if it's a quit event, we want to first quit out of Pygame, so pygame.quit, and run the exit command. So what's happening is that we're checking any events that happen at that moment in time and seeing if the user closed the program. We first quit out of Pygame. When we quit out of Pygame, the while loop is still running, so the program doesn't close. And so the best way from here to exit the program is to use this exit function. Now let's move on to what's actually on the screen. We'll set up the background first, and we'll do that at the top of the game loop. And so to set the background color, we do screen, which we remember we set as the canvas or display earlier, and we'll do .fill, and then you enter for a color of choice. I'm gonna go with this dark purplish color because I want that space looking background, and it's important that this is at the top of the game loop. I will explain why in a couple of minutes. And so to finish the space background, we also need stars. And so to add stars, we'll come up here outside of the game loop, and I'm gonna create a class called stars. This will help us easily store the information of all the stars that are gonna be on screen. And so let's initialize them, def init. And then we also want two arguments. We're going to have the x coordinate and the y coordinate of each star. And so self.y coordinate equals the y coordinate that we pass in when we generate the star, and self.x coordinate equals the x coordinate that we pass in when we generate the star. And so now we need to actually generate them and store them in a way where we can easily access them, so we can move them around like you see. And I'm going to use dictionaries for this. So let's create a dictionary. Stars equals a blank dictionary for now. And I'm going to create 300 stars. So for I in range 300, we're going to add a new pair to the dictionary. So stars, and we'll do f string for the number I, and we'll set it equal to an instance of stars. So this is where the randint function comes in that we imported earlier. And because our screen is 1000 pixels long, we want our stars to generate anywhere from x coordinate 1 to 999. And for our y coordinate, we know the width of our screen is 500, so I want the stars to generate anywhere from 1 to 499. And so each item in the dictionary is an instance of the class. The terms and definitions are the x and y coordinates. These are pairs. And so now, for them to actually show up on screen, we need to go into the game loop, and we need to iterate through each pair in the dictionary and draw a circle at the x and y coordinates. So to do that, we'll come here under the screen.fill. So we'll do for I in stars, which is our dictionary, to draw in Pygame, we have to do pygame.draw, and then you pick from a shape. I'm going to do circle, and so you have to pick a surface. It's going to be screen. So now you know why it's important to do the stars under screen.fill, because in Pygame the way it works is that each surface, when we draw a surface, which in this case a star is a surface, the background is our surface, our future characters are going to be surfaces, they layer on top of another. So the latest drawing that you draw will be on top of whatever was already drawn. So in this case these stars will be on top of the screen. We're also going to give them a color. I want them to have like this cool yellowish color to make it actually look like a star. And then finally we need to enter in the coordinates, and this is where the classes and dictionaries come into play. For the x coordinate, I have to get this value from the dictionary pair, so we'll do dictionaries bracket I. This will give us that pair, and from there I'm gonna get the x coordinate, and I'll do the same thing for the y coordinate. Y coordinate. Now you see why I use classes and dictionaries. It's a lot easier to call out the x coordinate attribute of an instance simply, and it's easier to store the x and y values of that instance as pairs in the dictionary. I also want the stars to be moving backwards, so it looks like our spaceship is moving forwards. So I'll do that by coming down here, and each time the game refreshes, I'm gonna change stars bracket I x coordinate, and I'm gonna decrease it by 0.5. And also here we need the radius of the circle. I'm gonna have it be 1 because I want the stars to be really small in the background, so the radius is 1 pixel. Alright, let's try running the program. Oh, that looks really neat. We can see the stars moving backwards. However, you can notice here that once the stars go off screen, they stay off screen, and then here we're just left with an empty void. And so there's a very simple solution for this. Instead of generating new stars every time they go off screen, we can simply just send the old stars that went off screen back to the other side of the screen. So we'll do if stars bracket I dot x core is less than 0, meaning they're off the screen, we'll just change the value of the x core dot x core back to 1000, which is the other side of the screen. Now let's see if it works. Now we have a nice moving background. So now that the background is ready, let's work on the foreground. And so the first thing we want to create in the foreground is the player's class. And it's the player's character. I will also do this using a class. So let's come up here and create a new class for our player. So class, and we'll call it Spaceship because our player is a spaceship. And unlike our star class, we want this class to be a sprite class, so we can access a lot of the tools from the Pygame sprite, and this will help us do important things like putting the character on the screen, and it will be important for checking for collisions later on in the game. First we have to inherit the Pygame sprite, the features from the sprites. So we'll do that by typing pygame.sprite.sprite. This will give us access to the sprite features. And now when we're initializing it, def init self. We don't need any arguments when we're creating the instance for this. And to actually use the sprite features, we need to actually tell the class that we're going to be using these. So we do this by super and then dot init. Alright, so for sprite classes, and to actually have them show up on screen, we need two attributes. We need the image attribute and we need the rectangle attribute. That's the rectangle around the image. So first let's load in the images. We'll create a variable called ship image, and I'll set it equal to pygame.image.load, and then you add in the file name or file path. And for ease of conversion and to make the game run a bit smoother and for the game to look better, we do .convert alpha. And because I know my image isn't properly scaled, we're gonna have to use a function called rotozoom to change the size and rotate it so it's positioned the way I want. So for that, we reassign the ship image variable to pygame.transform, and then we use the function rotozoom. And we have to first pass in the variable of the surface that we're going to change. And then first, to rotate it, I'm going to have it rotate -90 degrees. And I'll scale it to 0.65 or 65% of its original size. And as you saw in the game, my spaceship has an animation for the boosters, and that's simply just two images constantly switching back and forth. And to do that, I created two ship image variables, the second called ship image 2. I set it to the other image, so pygame.image.load. And of course .convert alpha to make the game run smoother and for it to look better. And I have to rotozoom this one as well. It's basically the same image, so I'll just copy what I did up here and change the variable name _2 and _2. And so to easily be able to switch between the two, I created a list containing the two images, which I called ship image list. And this is just equal to ship image, oh that's spelled wrong, and ship image 2. I also want to create an index variable so we know which one of these two items to access from the list, and I'll call it ship image index, and I'll set it to 0 for now. And these two have to be attributes because I want to do this animation in a method. And before we move on to the method, let's actually create the attribute called self.image, which will be equal to self.shipImageList, and with the index self.shipImageIndex. And this way it will be one of these two ship images. And finally the rectangle around it, self.rect equals self.image, and to get the rectangle around the image, Pygame has a function called getRect, and I'm also going to set the center of the rectangle to 150, 250 on our display. This is the coordinates of our ship. Alright, so now let's move on to the method. We'll call it ship animation, and we're just gonna pass in self. And so we're going to run this method every time the game loop updates. So every time the game loop updates, or our refresh rate, I want self.shipImageIndex to increase by 0.1. This will keep our index value changing, and it will help us switch between the two images. And we also want to make sure when the value of this index goes beyond the index values in the list, which is 0 and 1, we want to reset the index value. So if self.ship image index is greater than the length of self.ship image list, we'll just reset self.ship image index back to 0. And finally, we want to change the value of self.image, and we'll just do self.image equals self.ship image list, and again with the value, and it needs to be an integer value, because here we're creating a float number, so we want to make sure we convert it back to integers. And self.ship image index. Alright, and so that's our animation function. And so because we're gonna have multiple methods for the spaceship class, we'll create one method called update, and in that we'll run the other methods. So self.ship, we need to pass in self into update. Self.ship animation. So now we need to create the instance. So we'll do, and so because this is a sprite, we also need to create a group for it, even though it's just one sprite. It will be called player, and we'll set it equal to pygame.sprite.group single. This will later allow us to update the sprite and actually draw it. And so now let's create the instance. I'll call it main character, and that will be an instance to the spaceship class. And I'll add a main character to our player group. And player is just a list, and so I'll add main character. It's just a list of sprites in this group. So now that we've created our main character, we can come into the game loop, and we'll do this in the game active section. We can do player.update, and to actually put it on screen, we need to do player.draw, and we need to tell it the surface, which for us is the screen. Alright, so now let's test the program and see if everything's running smoothly. And it is. We can see the stars are moving back slowly, and there's an animation for the player. Let's add control so the player can move around the ship. So let's go back up here to the class, and we'll create a new method. We'll call it movement, and we'll pass in self. And so we need to check for when the player presses any keys. So Pygame creates a list of keys that are pressed at any given moment, and we can access this by using pygame.key.getPressed. This will return the keys that were pressed at the moment this function was run, and we'll store it in a variable in a list called keys. And so now we can check for what keys were pressed, and then we can tell the game what to do from there. So if we'll do arrow keys and WASD for this game. So keys contains pygame.K_S, which is to go down, or keys contains pygame.K_down. And we want to make sure that the game is active, because we don't want them moving the ship when game's over or other stuff. So if this is true, we'll change the y value, self.rect.y. This is the rectangle of our spaceship instance, and we'll change the y coordinate and increase it by 5. This, unlike a normal coordinate graph, this will move our character down, because the Pygame plane, as you move down, the y value increases. And let's also add keys so we can move the spaceship up. So if we'll first do keys contains pygame.k, and this is w, or keys contains pygame.k.up, underscore up. And again, make sure game is active. We'll do self.rect.y minus equals 5. We also don't want the ship going off screen, so we'll set a boundary at the top and the bottom of the screen. So here, when we're moving the player down and adding to the y value, we'll check if self.rect.bottom, which is the bottom of the rectangle, is greater than 500, because remember that's the size of our screen, the width is 500, so the bottom value of the screen is 500. We'll just set it back to 500, so it looks like it hit a wall. And we'll do something similar here if self.rect, and because this time it's moving, the plane's moving upward, we'll check if the top is less than 0, and we'll set it back to 0, so it looks like it hit a wall. And like our other function, we need to add this into the update method, self.movement. And so now we've already added an update, so now if we run the program, we can see the movement works. Now all it needs to be able to do is to shoot lasers, and for this I'm going to create another class and I'll call it lasers, and I'll do this up here, class, and I'll call it laser. And this will also be another sprite class because we'll use this to check for collisions. Pygame.sprite and initialize it. And now for this we'll need a couple of arguments. We'll first need to know what ship it's coming from. Lasers will be shot from both the enemy and the player, and we need to know which it's coming from, so we know if it's a good laser or a bad laser. And we also need to know the coordinates of where it's shot from, so the x and y value. So first we'll do self.ship equals ship, which will be an attribute. And now I don't have an image for this one, and I instead drew this using Pygame. So I did that by doing self.image, and we have to create a surface, so pygame.surface, and for the coordinates I gave it a length of 40 and a height of 5. And now for the rectangle, self.rect will be equal to self.image.get rect, and the center this time will be equal to the x and y coordinates we passed in. And so finally, to draw them, we need to know the color. Let's say if self.ship equals the player, we'll do pygame.draw.rect, and it will be self.image, which is the image we created. The color will be red because it's the player, and it will be on the rectangle of the rectangle, and it will be the rectangle of our image. And then the last two arguments, one is the width of the border around it. Because the inside of the laser is hollow and it's just an outline, I gave it a width of 2 pixels, and the border radius to add the curves around the rectangle, I gave it a degree of 2, so it can be curved and look like a laser. And else, if it's not a player, we'll do the same thing. and change the color to blue. Alright, so now we've initialized our laser. We need to create the update function. And so as soon as the laser is shot, we want it to start moving in the direction it was shot. And so we need to know if it was coming from the player or the commander. So if self.ship is equal to player, we want self.rect.x, the x value, to be moving to the right 50 pixels. And if it was shot from the commander, we'll have it move towards the player, and it will be at a slower pace. We'll do 20. And if the laser goes off the screen, we can simply just kill it, because we don't really need the laser anymore. We can kill the sprite. So if self.rect.x is greater than 999, or self.rect.x is less than 0, we'll kill the sprite. Oh, and before we forget, also do super.init. Now we need to actually put them on the screen. So down here, where we created the player instance, we'll create 2 more groups. One will be good lasers and one will be bad lasers. We create 2 groups because we need to know which laser belongs to which side, and this will help us with the collisions later on. And so this time, because there's going to be multiple lasers on screen, we're going to do pygame.sprite.group. Not group single, but group. And so now that we have so many sprites on the screen, so the easier way to do this, instead of repeatedly doing player.update, good lasers.update, bad lasers.update, we can create, and .update for any future group we have. We can create a sprite list, and we can add player to it, good lasers to it, and bad lasers to it. And so this way, if we come down here, instead of doing player.draw, we can do for sprite in sprites, which is our list, sprites. So for sprite and sprites, we can do sprite.update and sprite.draw on screen. So this way, any future group or sprite we have, it all updates and draws in just these 3 lines. And so now to actually create the instances of the laser and spawn them on the screen, it will be a little bit different than the player who we create at the beginning of the program. We only want to create a laser instance when the player fires the laser. And so to do this, we need to check for the event in which the player presses a key, and we'll do this in the game loop up here where we checked for event in pygame.event.get. And the reason we check this in the game loop and we don't do it as a method in the class is because when we check it as a method, the pygame.key.getPressed function returns any keys that are currently pressed. This means the player can hold down the fire button, and we don't want this because it basically is overpowered. And so here, when we check in pygame.event.get, we're going to check for when the player types something, and that's only when the key is first pressed. So to do that, we'll do And we're already checking for events here, so we'll add another condition. If event.type equals Pygame.key down, which is whenever a key is pressed. If event.key equals Pygame.k, and we'll do space. And we also need to make sure the game is active because we don't want the player shooting if it's not active. We'll do good lasers dot add, and we'll create a laser instance, and we'll pass in the arguments, which is player, which is the type of ship, and we need to also reposition the x and y coordinates slightly so the laser matches up with the guns on the ship. So to reposition it, I'm gonna do main character, which is our ship instance, dot rect dot x, and I'll add 80, and main character dot center y. Want to make sure it's center y, and then add 40. This will be our bottom laser, and we do the same exact thing for our second laser. For our second gun, except this time it's just minus 40. Oh, and rect dot center y, make sure you don't forget that, dot rect dot center y. Now let's try running the program and seeing if the guns work. So now that the player is all ready, we need to add the villains. And so for our villain class, we'll start off the same. We'll do a class and call it villain. Inherit from Pygame.sprite. Then we initialize it. And we'll actually have another argument here because we have two types of villains, so we need to know which skin to put. And again, super dot init, and then as always we'll add the images. For this one I actually have images, so commander image equals pygame.image.load, and then you put in the file, and of course dot convert alpha. And I also need to transform these images too because they're not to proportion. So commander image equals pygame dot transform dot rotozoom, and commander image is the surface we're changing. We're gonna rotate it 90 degrees, and we're gonna resize it by 0.6. And now for our second villain, this one is a nuke. So let's do the same thing with the nuke image. Nuke image equals pygame.image.load, and then dot convert alpha. And I also need to transform this one because it's not to scale. Pygame.transform.rotozoom, the nuke image. We're going to rotate it 90 degrees, and this one will be smaller than the commander, so we'll do 0.3, so 30% of its original size. And we're going to do something similar to what we did while we were animating the player ship. We'll create a list with both images, villain skin list, and we'll add both commander image and nuke image, and we'll create an index variable. This one will be an attribute, so we can use it in other methods. Self.skin index, and this is equal to the skin argument that we pass in. And finally, we need to actually create the image and rect attributes. So self.image equals villain skin list, and it will be self.skin index, and the rect attribute self.rect equals self.image.getRect. We'll have the center, and because we want the spawn of the villains to be random anywhere across the y-axis on the right side of the screen, we'll first set the right side of the screen coordinate. It will be 1000, or we'll set the left coordinate, the mid left of the rectangle. We'll set it to 1000 so it spawns off screen, and then a random integer anywhere from, we'll constrict it from 1000 to 4000, so there is a range of where it can spawn, so it doesn't spawn anywhere like off screen or in an area where it's like slightly off screen or it's hitting the health bar or something. So now let's work on the commander being able to shoot a blue laser. So we'll do def shoot, and in this method we'll only spawn the laser, and we'll actually control its movement in the update method because it's a little easier that way. Alright, so if self.skin index, here we see that the commander index is 0, so equals 0. We'll create a new instance called bad laser, and it will be an instance of the laser class. It will be a commander, and the x and y coordinates can just be self.rect.x and self.rect.center y, and finally add it to the bad lasers group. Bad laser. Alright, so it's actually easier to control the laser in another method, and so we'll control it in the update method. So def update, and we'll only need self. First we want the commander or just any villain in general to be moving towards the player, and so the x coordinate will decrease, so self.rect.x minus equals 10. And also we want the commander to go a little slower than the nuke because it's a bigger object. So we'll do if self.skin index equals 0, and we also want to make sure that so it's visible on the screen, so we'll do self.rect.center x is less than or equal to 850. This just to make sure that it starts slowing down when it's on screen instead of it just always being slow, because we want it to approach the player and then slow down. Alright, and I'll slow it down by simply just adding self.rect.x, and I'll do plus equals 8. So this time if you do the math, the commander is only going to be moving towards the villain 2 pixels every time it refreshes, as opposed to the nuke that's moving 10 pixels. So now for the lasers, we want to shoot the lasers once every second, so we need to know when the laser was fired and what the time is right now. So we needed to create a variable that contains the time at which the laser was shot, and we'll create we'll create it when we create the bad laser instance. So we'll do self dot, and I'll call it laser cooldown, and we'll set it equal to 0 for now. And now in the update method, we'll create a variable that contains the current time, so we know what the time is. So now equals, and to get the current time in Pygame, you type pygame.time.get ticks, and so that will assign the current time or milliseconds since the program started to the now variable. And we want to check if the time between now and when the laser was shot is greater than 100 milliseconds, which is 1 second. So if now minus self dot laser cooldown is greater than or equal to 1000, what we want to do is we want to run the shoot command. So self dot shoot, and we'll update the self dot laser cooldown attribute, and we'll set it equal to now, which we just set. And also, because the villains are moving and we don't really want them to come back, they're just going to be one-time like ships that just keep going, we'll do the same thing we did with the lasers, and if they go off screen, we'll kill the sprite. So if self.rect.x is less than 0, we'll do self.kill. Oh, here when we set self laser cooldown, we don't want to do it in the shoot function, because then it will just never run. So we want to do it when we initialize our class or instance. Oh, and also make sure these are not indented in the init method. They should be their own method. Oh, and make sure this is cooldown, not calldown. Alright, so now before we can actually put the enemy sprites on the screen, we need to create the villain sprite group as we did for all other sprites. So let's come down here and let's do villains equals pygame.sprite. And this is going to be group because there's going to be multiple activated at a time. And we'll also add this to our sprites list. Alright, so the way we're going to spawn the villains is we want them to spawn every 800 milliseconds, and to do this we have to create a custom Pygame event. It's similar to when we're checking for the key press event, but it's our own custom event. So down here, let's call this villain spawn. That will be the name of the event, and we'll set it equal to pygame.user event, and we'll add 1 because there's already some functions going on during pygame.user event, and we don't want to mess with those. So for our own custom events, we add 1 millisecond so it doesn't mess with. We add 1 millisecond, yeah. And then to set the timer so it triggers every 800 milliseconds. We can type pygame.time.set_timer, and it will trigger the villain spawn event, and we want it to be every 800 milliseconds. So every time this event occurs, we want to create an instance of the villain class, and also we want to randomly generate either a nuke or a commander. So down here when we check for events in for pygame.event.get, we'll add a new condition. If event.type equals villain spawn, which was the name of our event, and we also want to make sure the game is active, we'll create a new instance of the villain class, enemy equals villain, and we need to pick our skin. And so this is where the choice function from up here comes in. This is where we're going to use it. So we want the nukes to spawn more than the commanders, because the commanders are a lot bigger, and they also shoot lasers, so they're going to be a bit harder to defeat. So we want them to be more rare. So here, when we use the choice function, we can add a list of options for it to choose. So we have 2 skins, 0 and 1. Those are our indexes for the list. And 1 is the nuke, and because we want the nuke to be more likely to spawn, we're going to add 1 a couple more times. So this way a commander has a 25% chance of spawning, while a nuke has a 75% chance of spawning. And finally, we'll add it to the group, villains.add enemy. Alright, now that we have the player enemy and the laser set up, now we can work on collisions, and this will help us determine the score and the damage done to the player, which are basically the core parts of any shooter game. And so let's scroll up to the top and create 2 variables. Lives, this is the amount of lives the player has, and we want a separate variable for lives remaining equals, and we'll set that equal to lives. And you'll see why we have 2 variables instead of just 1 later on. So let's create the function first. Alright, so we can create the function down here below the stars. So def, we'll call the function check player damage, and we'll pass in 1 argument. This is the current lives, and this is the value we want to change as the return value for the function. So this is where the sprite features in Pygame become very useful. It makes it really easy to check for collisions. To check for collisions, we can type if pygame.sprite, and because we want to check if our 1 player sprite is colliding with anything it shouldn't be, we'll do sprite collide. And so the arguments for this is first our player sprite. This is our 1 main spaceship, and then we pick a group of other sprites to check for collisions, and the group we want to check with is villains. And this is a boolean value, which basically means it basically dictates whether or not the sprite that collided with the player, the villain sprite, if it will delete that sprite or not, and we want to delete it, so we'll do true. This basically means that when the 2 collide, the enemy sprite will disappear. And if this is true, we'll do current lives minus equals 1, and we also want to check if the player collides with the bad laser group. So if pygame.sprite collide, then of course player.sprite and bad lasers. This is why I separated the good lasers from the bad lasers group as well. And true. And because lasers are weaker, we'll reduce lives by 1 here, and we'll increase this to 2. And so when we check for scores, and when the player hits a villain, when the good lasers hit a villain, we're going to use a similar function to sprite collide, but it's going to be slightly different, and I'll explain the difference when we get there. And also, before we forget, we don't want the lives to be a negative number, so at the end of the function, we'll do if current lives is less than 0, we'll reset it back to 0. And finally, return current lives. So now in the game loop, we want to run that function when the game is active. So we want to update the number of lives remaining. So we'll do lives remaining, which was our original variable, and we'll set it to check player damage. Oh, I spelled that wrong. Oh, let me fix the spelling. Alright, check player damage, and we'll do lives, and we'll pass in lives remaining, which is our current lives variable, and let's print lives remaining. Let's run the program now. Oh, the damages work. We can see the values going, we can see the lives going down in the terminal. Alright, it looks like the game keeps going even after there are no lives left. So let's work on ending the game. So in the game active section, we can check if the player has any lives left. Here, if lives remaining is equal to 0, we can do equals 0. And so once that happens, we want to get rid of all the sprites that are not the main character. So the good lasers, bad lasers, and the villains. So an easy way to do that, so the best way to do that is to come up here. We'll create a new list called NPC, and we'll add everything that's not the player. Alright, and now down here, we can type for group in NPC, we can do group.empty. This clears all of the active sprites. And then we want to change the boolean values of this NPC. Then we want to change all of the boolean values of the sections of the game. So we'll do game active equals false. We can do home screen equals false. And we can do game over screen equals true, because we want that to happen. And also for later purposes, we also want to know the time the round ended. So game over time is equal to pygame.time.get ticks. So before we actually move on to what happens after the game ends and the score, we also need a way to show the health the player has remaining on the screen, and we'll do this using a health bar, and we'll do this in our check player damage function. So here, even though this is being shown on screen, I'm not gonna use a class for this because it's not really interacting with any of the other sprites on the screen, and we don't have to hold a bunch of important information about, like, for example, the stars. We had to hold the X and Y attributes. Here we don't really have to do any of that, so I'm not really gonna do a class for that, and we'll just draw it using Pygame. So to do this, I don't have an image for this, so it's similar to the lasers where we draw an image. So first we'll create the surface, so health image I'll call it, and that's equal to pygame.surface.surface. Then for the coordinates, the size, I'm going to do the integer value of current lives and multiply that by 30, because that's going to be the size of each bar, comma 30 can be the height of the health bar as a whole. And so that will be standard. We have to draw the rect, so pygame.draw.rect. It'll be health image, and I'm gonna have it be the same color as the ship, so the player knows that, oh, this is my health bar. And health image.getRect. And so now to actually put it on screen, this is going to be a little different. Instead of just drawing it like the sprite classes, we have to use a more traditional method. In Pygame, if we want to put a surface on top of another surface, in our case the screen, we have to use the blit function. So first, the bottom surface for us is screen.blit. Then the surface we want to put on, so health image, comma the rectangle value, health image.get rect, and inside I'll give it the coordinates, the top left coordinates. I'll have it be 80, 50. Alright, so let's test this. Oh, and it's working every time the player's hit, the health bar goes down. Oh, there's an error. Oh, it's for the empty down here. Oh, I spelled this wrong. Empty. Alright, let's go back up here. And so as we saw, it kind of just looks like an orange square, and so to make it look better, I'm gonna add a gray border around it, so that way it doesn't just look like a random square on the screen. So let's do health bar outline is equal to pygame.surface.surface, and this will be lives, our total amount of lives the player has, times 30, and 30 again for the height. And this time, oh, this is supposed to be all in coordinates, and this time I'm also gonna add one more argument, that is pygame.scr alpha. This will allow the middle of the surface to be hollow, so we can see the orange health bar behind it. And so then pygame.draw.rect, this will be the health bar outline, the color will be gray, and the health bar outline .get rect. And I also want to add a width. The width of the border is going to be 5. And then finally, to add it on the screen, screen.blit, and then health bar outline, and health bar outline .get rect, and I'll give it the same coordinates, top left equals 80, 50. And just to go the extra mile, let's also add text that says there's a health bar, so the player can't get confused. We're gonna create a font. We'll call it text, and it will be equal to pygame.font.font. So this is a font, and then you can pick a font that you downloaded, or I'm going to, for this, use none. This is the default Pygame font, and I'll give it a size of 40. So now to create the text, if we come down here into the function, down here. So to create text, we need to create a surface variable as always, and it's a little different than drawing a circle or the square. We need to create a surface and render our font saying whatever it is we want to say. So we'll do health text is equal to text, which is our font, dot render, and then it will say health bar. Then this boolean, it's not very important, and then the color, I'll have it be the same color as our health bar. Then create the rect, health text rect is equal to health text dot get rect, and I'll give the coordinates top left equals 160, 120, so it's kind of in the middle above the health bar. And then finally, to add it on screen, it's the same, screen.blit health text comma health text rect. Alright, now let's run it and see if it shows on screen. Yup. Oh no, this is below. Oh, this is not 120, this is supposed to be 20. Alright, now let's move on to the score. The score will be the number of enemies the player hits. So here we'll do score equals 0. And for later purposes, I'm going to create a list called collisions. It's going to be empty, and this I'll explain why later. It will basically help us to do the +1 whenever a player hits the enemy. So let's go down to the function. We'll go def update score, and we'll pass in one argument, that's the current score. And we'll use a similar function for collisions that we did in check player damage, but this time it will be group collide. So we'll first store it in a list called collide, and it will be pygame.sprite.group collide. This is because previously we were checking if only our one player sprite was colliding with any of those groups. Now we're checking if the good laser are colliding with the villains. There could be multiple lasers and villains on the screen at the time, so there could potentially be multiple collisions at a time. So we'll do the good lasers and the villains. And this time the booleans at the end will both be true, because when the good lasers hit the villains, we want both of them to disappear, because like both of them got eliminated. And so this collide list will help us with the +1. So it's basically a dictionary that contains the coordinates of the collisions that happen. So we can check if a collision happened just by checking if collide, and this will check if there's anything in that dictionary. And so now we have to iterate through the items in the dictionary and extract the x and y coordinates, which are the terms and definitions. So for moment in collide, we're iterating through each item in the dictionary. And then for place in collide, this moment or place, it doesn't really matter, I'm just using those. So first we want to update current score, so we'll do +=1, and we also want to add this collision to our collisions list, so .append, and we'll first do the coordinates of where it happened, so place.rect.center x, place.rect.center y, and the time it happened, so pygame.time.getTicks. And so this is all in one item, and so we'll be able to extract this using comma splices later on. And also, before we actually put this into the game loop and do the +1 stuff, let's also create the scoreboard. And it's going to be pretty much identical to when we did the health bar text, but we also want to add the score value into the text. So first we'll create scoreboard, which is our surface. We'll do the font again, .render, and here we're going to type score, and we're going to concatenate the string value of our current score. And then again, true, and I'll have it be white. And now let's create the rectangle, scoreboard, comma rect. Underscore rect is equal to scoreboard dot get rect. Oh wait, this is not font, this is supposed to be text. I was saying font and then I wrote font. And then the coordinates will be top right is equal to 920, 50. So it's kind of like on the other side of the screen to the health bar. And then we have to actually add it. And then we have to actually add it onto the screen. So screen.blit scoreboard and scoreboard rect. And then finally we want to return the score value. So now in the game active section, we'll also do this. We can remove print lives remaining because we have the health bar, and we'll do score. Oh, I misspelled score, but whatever. And update score, and I'll pass in score. And we also want to know the high score, so I'm gonna create a list called scores. It'll be empty, and then down here when the game ends, I'll do scores dot append, and then our scores value. Alright, let's test this by running the program. Oh, the score increases every time we hit a villain, and our player health still goes down, and all the sprites disappear. So down here, let's add the 1+ on the screen. So because we have a list called collisions, we want to iterate through the list. For collision in collisions, and we want to take out the 3 pieces of data: x value, y value, and the collision time, and that will be equal to the collision value that we extracted. And so now we only want the +1 to be up there for like half a second, so we'll do if pygame dot time dot get ticks minus collision time is less than 500. We'll add the text on the screen. So we'll call the text surface point indicator, and it will be our text font dot render, and it will say +1. I'll do true for this one again, and we'll have it be white. Then to create the rectangle, point indicator rect is equal to point indicator dot get rect, and then the center is equal to the coordinates where it happened, x comma y, which we passed in, and then finally add it on the screen. Screen dot blit point indicator at point indicator rect, and then we'll do else. We'll just do collisions dot remove collision. Alright, so let's see if this is working. Oh, and it works. The +1 should pop up wherever it happened. Now we actually have our main game running. We just have to build the rest of the screens. There's the home screen, cutscene, and game over screen. So first we have to change the values of the booleans at the top of the code. So we want our game to start out at the home screen, so we'll change that to true, and we'll set game active to false. So now that we start at the home screen, we need a way for the player to actually start the game, and so the easiest way to do this is for checking a key pressed by the player. So we'll go down to where we checked for the keys in the events. Here we'll add another one. We'll do if event dot type, or we already have a pygame dot key down section here, so we'll just add one more condition. So if event dot key, and we'll make it, the designated key will be pygame, will be enter, or return k underscore return. And we also want to make sure they only do it while it's home screen. And we'll do game active equals true, as well as home screen equals false. So now we can work on the home or title screen, whatever you want to call it. So I'm gonna actually create a new font for the title. So I'll call it title font, and then I'll make the size 80 because I want it to be a little bit bigger. So now if we go down here to the home screen, we'll create new text. So title equals title font dot render, and I'll have it say, we'll call it Pixel Wars, true, and then I'll have the color be white. Then let's create the rectangle. So title underscore rect equals title dot get rect, and I'll make the center exactly in the middle of the screen, so 500, 250, and then I'll add it on the screen. So screen dot blit title, and then title rect. We can also show the score the player got on the last round, and we can have this be above the title. So I'll do another scoreboard variable, and I'll do title font. I'll use title font for this one as well. Dot render it will be the same thing. Score, and then concatenate the string of the score. True, and then I'll have it be white. And then scoreboard rect equals scoreboard dot get rect, and I'll have the center be just above the titles. And then screen dot blit scoreboard at scoreboard rect. And in addition to the score, we'll also put the high score, and we also need to make sure that if the player hasn't played any rounds yet, it will display none. So we can do that by checking if scores. So if there's anything in that list, we'll do the normal. It will just be high score, which will be our surface, equals, and I'll do title font as well, dot render high score, and then I'll concatenate the string of the max value of the scores list. And then true, and then I'll have this be blue just to add some color. And then else, we'll do the same thing, but we'll change this to just none. And I'll also add high score here. And then we'll add this on screen. So high score, actually. High score rect equals high score dot get rect, and the center will be slightly below the title. And then add this on screen. So screen dot blit high score add high score rect. And finally, the last thing to the home screen, I want to add the player ship so it's visible and the player knows what he is on the screen once the game starts. So first we'll set the position of the ship manually by doing player.sprite.rect.center equals 100,250, and then we'll draw it. So player.draw screen. And this is going to be slightly further back because when the game starts and the cutscene happens, the player moves forward a bit to make it look like it's moving closer to the enemy ship. Alright, let's run this. Oh, there everything is. We also can't move the player, and then when we press enter, the game starts. And so now let's work on the game over screen. So we want it to say game over and display the score. So what's saying game over? I'm gonna do the exact same thing as title. So I'll call this over is equal to title font dot render, and we'll say game over in all caps. True, and we'll have the color be red because the player died. And then the rect equals over dot get rect, in the center will be at 500.250, so the middle of the screen. And then screen dot blit over at over rect. And displaying the score is the same too. I think I'm just gonna copy the exact thing that we did. And we also want the game over screen to end after some time. I'll think we'll make it 30 seconds long. So we'll check, and so this is where the game over time variable comes in. So if pygame.time.get ticks, minus game over time is greater than 2,500 or 3,000. We'll make it, I said 3 seconds, right? We'll do game over screen equals false and home screen equals true. Alright, now let's run this and make sure it works. So we have to die first, which is kind of hard for me to do. Oh, there it is. And it ends after 3 seconds. Now let's work on the cutscene that happens when the player starts the game. And so this is when the player is traveling to the enemies. So first we need to update what happens when the player hits play. So up here when we check for key pressed, instead of setting game active to true, we're going to set the cutscene to true. And also I'm going to create a variable called cutscene time, and I'll set equal to pygame.time.getTicks. This is to be able to control how long the cutscene is. So down here, for the cutscene. So because the ship speeds up to travel to the enemies, we want the stars to speed up their movement in the background so it looks like the ship is moving faster. So we'll do a similar thing that we did originally for I in stars. We'll do stars, comma I dot xcore, and then I'll increase it to 30. And we'll still keep this the same if stars bracket I dot x core is less than 0. We'll do stars bracket I dot x core, and we'll send it back to 1000. And we also want the player to move forward slightly too, just to make it look like the player is moving a little and not just the stars. It makes the game feel more real. So player dot sprite dot rect dot x plus equals 1, then player dot update and player dot draw screen. And now at the end of the cutscene, we need to reset the scores and lives as well as start the game. So if pygame dot time dot get ticks minus cutscene time, and I'll have it be 1200 seconds long. We'll do lives remaining equals lives, and then we'll do score equals 0, cutscene equals false, false, game active equals true. And now let's try running the program. Alright, the cutscene works very well, but we can also see that the stars end up forming these lines, and this is due to like the refresh rate and the movement of the stars, and it's kind of complex to really fix all that. And so the easy solution I'll just go with is create new random locations for each stars. So for I in range 300, we'll do stars f string bracket I equals stars rand int, and then 1 through 999, comma rand int 1499. So this way the stars basically get reset. Alright, so now that let's run the game. Hope you can see the stars reset. And that's the space shooter game. Hope you guys found this tutorial useful. Please comment any questions or suggestions you have about the video, and thank you so much for watching. See you in the next one.